Our speaker today for the Math Interest Group is Bapi Sen, who's going to give a talk on 7 ways AI can fail. Now, what I like to do is I like to give a bit of a foreword on artificial intelligence. The terminology in AI used today is a catch-all for any and all algorithms that try to do something at the level of what humans can do. They generally don't specify which ones or how they are used. In general, the technology looks at problems in pattern classification. That starts off with statistical methods like Bayes' decision theorem, using Bayes' theorem, minimum error rate classification, Neiman-Pearson criteria, maximum likelihood parameter estimation. So these methods progress to matrix and other methods that include principal component analysis, which is Fisher linear discriminant, hidden Markov model, and nearest neighbor estimation, fuzzy logic, decision trees, and such as classification and regression trees, also known as CART. So eventually these classical approaches gave way to methods that model the human brain, namely artificial neural networks, its successor, convolutional neural networks. These networks are required training set to teach them under a supervised condition, but the biggest progress is to use a method of unsupervised learning where the neural networks can basically teach and learn themselves. And this is something that biological life seems easily to do, but it's actually very hard to do in practice. When a company advertises its self-driving car using AI, it never specifies which of any of these algorithms are used. In general, it's presumed that at least neural networks is used, but many parts of the system may also employ some other methods listed. The exact details are always held secret. So AI referred to is mostly associated with neural networks as a primary method, but in my estimation, there are many other components and methods used within the whole system. So today's speaker, Bapi Sen, has given us a number of talks for the Math Interest Group in the past. So these include limitations of artificial intelligence, which covered how emotion and intuition is not reflected in AI, responsible AI, which covered how inadvertent biases can creep into AI, beneficial AI, combating COVID-19, which covered extracting useful info from large data sets to combat COVID, and detecting COVID coughs with AI, which covered detecting subtle acoustic variations in coughs to help doctors identify COVID cases. So Bapi will also give us benefit of his knowledge of operation research in this talk. So please welcome Bapi in giving his talk on MIG for 7 ways AI can fail.
So you have my first slide. You can see my first slide.
Yes.
I'm sorry for all this stuff. No. AI has always suffered numerous, sometimes deadly failure. Although I previously talked about how AI could help people in many ways, this talk is going to be revealing that there are some things that we have to be careful. The reason we have to be careful because AI fails in a number of ways. The first one is brittleness. I'll talk about brittleness in a second. The second part is embedded bias. Third is catastrophic forgetting. Fourth is explainability. And fifth is quantifying uncertainty. Sixth is common sense. And seventh is math, pure math. So AI, in considering AI, the most reason of the AI fails, the AI is based on some concept called neural network, which has its own drawbacks. Let me go to the first slide, brittleness, the first criticism. If you see a school bus, which in an accident will go on its side, and 97% of the time, a 3-year-old child could identify that's what happened. But AI failed to see that. It talks about it to be something else altogether. And this brittleness property has some issues. Now, computer scientist Anne Nagun commented about brittleness was partly mitigated by advances of deep learning. Parallel deep learning system can beat the expert in difficult game of Go. And Jan LeCun said, what's missing is a part principle that would allow machine to learn how the world works by observation and by interaction with the world. A learning predictive world model is we are missing today. In my opinion, the biggest obstacle to significant progress in AI. See, predictive world model is we are missing. Nicholas Roy said the requirement of deep network are to an extent misguided with the requirements of army mission and the problem. In the earlier days, the deep network problem was solved in areas of army mission with simulation, and that is the only way to do it. And in terms of social network or anything, this does not work as well. The embedded bias is the second criticism. Increasingly, AI used to help support major decisions. 2019, scientists found nationally deployed healthcare algorithmization bias. See, although AI can support major decision, and the major decision could be very biased because it inherits the biasness of the people who it put together. For instance, there are studies which found that that AI has inherited the same biases as its AI, the person who put together the ideas. So that's a big embedded bias in the second criticism. Now, consciousness in AI is an issue that was raised because of the biases. Now, John Searle, who's a philosopher at Berkeley, who gave a Google talk to Google, which is available at YouTube, and they talked about why consciousness is not there in terms of AI advances. I knew John in 1967, 72, and one of his important points that he made at that time is about moon landing. That's the early days of moon landing. He says, people think that AI not AI, but moon landing example was that you think in one dimension, and they said that by computing the thrust necessary to have moon landing was impossible. But then they started thinking that if the spaceship goes around the world and then shoot out, that that would be useful for moon landing. Now, moon landing analogy is the first time what Stuart Dreyfus and Howard Dreyfus of IUR department and Howard Dreyfus IUR department was collaborating together on the limits of AI in the Mind Over Machine book that I talked about previously. So the trouble with AI is the consciousness is not totally understood. Deep mind training in case of game of Go, for some, that's a worrying thing, especially when they consider the deep mind system in more ways than one, teaching itself to play. The system isn't just learning from the data provided by humans. It's learning by playing itself, by generating its own data. In recent months, Tesla founder Elon Musk and others have voiced concern that such AI systems eventually could exceed human intelligence, which is multifaceted, a potential break free from our control. But deep mind system is very much under the control of Hesebis and his researchers. And though they used to crack a remarkable complex thing, it is still just a game of Go. Indeed, AlphaGo is a long way from real human intelligence, much less super intelligence. This is highly structured situation, says Ryan Callow, an AI-focused law professor and the founder of the Tech Policy Lab at University of Washington. It's not really a level of understanding, but it points to the direction of the deep mind's AI and understanding Go. Then maybe it's understood a whole lot more than the universe, Callow said. It just is a giant game of Go. So this is the embedded bias, and the third criticism is the catastrophic forgetfulness. The next point that happened is what happens is the catastrophic forgetfulness, the third criticism. What happens is in catastrophic forgetfulness, you train AI to learn something from the neural network. And what happens is all of a sudden, when you train something else, or they already completely forget what was previously. For instance, computer scientists and colleagues at South Korea created a website where people could update images to check in authenticity. In the beginning, the researcher trained that neural network to check the authenticity. After a few months, new types of deep thing emerged, and when they trained their AIs to identify these new varieties of defects, it quickly forgot to identify the ones that they're doing. The criticism by Stuart Dreyfus and Howard Dreyfus in 1960 made model is still true, though. In this paper in 2021, Scot, Rousse of pluralistic networking at UC Berkeley and Stuart Dreyfus revisited the introduction of the perspective deliberation, that is, this calculative deliberation characteristic of lower stage of skillfulness. The skillfulness is further understood by the perspective deliberation. Explainability, however very precise, is getting stuck. Fourth criticism. Explainability, very precise, is getting stuck. which is the fourth criticism. The explainability is you try to explain by a flow chart, and then you get into a spaghetti thing, and the explainability cannot be understood, which is the fourth criticism of AI. For instance, the explanation of a prediction that person may be criminal or have cancer, the explanation and the other prediction can have many legal, medical, and other consequences. Hobbes Nagun say explaining theory is getting stuck when it tries to explain things. Fei Li of Stanford Institute of Human Center AI is fundamentally an applied technology that's going to serve our humanistic idea. AI that only raises the awareness of the importance of the technology. It's really important way to attract diverse student technology and innovation to participate. So that's the positive part of it. But the thing about it is the explainability is getting stuck, really explaining what the problem is. Fifth criticism of AI is quantifying uncertainty. What happens in the AI case, you use to quantify uncertainty. But what happens when you quantify uncertainty? It's not, it's counting the chips in a wrong way, and it's not doing what we do. For instance, Chelsea model car accident showed uncertainty calculation is not par yet with human making the split second decision. For instance, when I worked in the Defense Department in the early 90s, early 2000, US Army was a bad to team up human and robot in the battlefield. But this is all about simulation, but still simulation can be visualized to use in the terrain. You still need to pilot to take over control when some unexpected situation happens. So driverless car is a far away from reality. For instance, if you are in a plane, for instance, where there's no other obstruction, even then, when plane gets into some problem, a pilot has to take over. So human decision making is needed in case of changes situation. So the human visualization is important to take control, and that's very important in the decision-making process. The sixth criticism is common sense, which is the sixth criticism. Sixth criticism is, for instance, you can see here AI might be able to produce some understanding of the situation, but the high-flown things might be not good enough. And you can see that the person who has no common sense will be cutting the tree when she's sitting. And this kind of common sense is the sixth criticism that AI has. There are some computer scientists, which are assistant professor of computers in the USC, they can learn shortcut that could train them to misbehave. Natural language processing, common sense, reasoning, machine learning, knowledge graph information extraction is there, but not doing the job it is supposed to do. Some other in the field, like Jason Watson of Facebook and Drew McCallum of the University of Massachusetts, John Wu of Microsoft Corporation, has thought through these issues, but it is not still in the position that we could think of. The last criticism is the simple math. Berkeley's Hendricks says math problem uses human brain parallel computing power. It's easily make mistakes solving simple math problem. So you have parallel computing power. With all that extra power, it can make 2 + 2 = 5. Could be mistaken. And the parallel computing power is not able to solve simple problems. For instance, some of the concern and resolution, of course, of some of these issues are that, especially when they consider the deep mind system, is in more ways than one teaching itself to play Go. The system isn't just providing data provided by humans. It's learning by itself, by generating its own. But deep mind system is very much under the control of humans, as Hassabis and the University of Cambridge and his researchers say. And though they used to create remarkable complex game, it's still just a game. Indeed, AlphaGo is a long way from human intelligence, much less super intelligence. This is a highly structured situation, says Ryan Kello, AI-focused law professor and the founder of the Tech Policy Lab in the University of Washington. It's not really human level understanding, but it points out in the direction. If deep mind AI can understand Go, then maybe we can understand a whole lot more. What is the Gallo says is just a giant game of Go. It's a game that can be solved, but in real life situation, it cannot do it. For instance, deep learning to move, it needs a lot of power. For instance, to sense that something on the way, they have to have a lot of control robotics. It's really as a situation that control robots. So it needs a lot of power and a lot of machinery to do something like avoiding the obstacles in front of it. So the most of the system that we talked about is in the deep learning is a problem. The power.
Okay, Thank you,
My
Bapi.
conclusion of my talk, I owe my training to many of the people. AI system is devoid of human intuition and feelings. Calling it has a human level intelligence, most difficult to define, is a far cry. The recent New York Times article in May 23rd in business section article says, why isn't AI increasing productivity? It's a good example. For instance, AI has all this power, computing power, but it's not really increasing productivity because it's kind of mechanizing obvious things that low-level people could do, but it's not really increasing the productivity situation. It can be considered its limitation. AI can, if we can consider its limitation, AI can be used to solve many challenging problems humankind faces today. For my talk today, I owe my debt to a number of people like Ardley of Pacific Telesis, number of my professors at UC Berkeley, Stuart, Dreyfus at IEEE, Richard Cobb of computational complexity, David Gale at LP and duality, Ravi Bhattacharya at probability theory, Pravin Varaya of stochastic control theory, Dan Zig of linear programming. So the problem that I face today, when I research it, I owe all these individuals for my training and work. So that's all I have as a, it didn't take me enough time, but I know will be willing to.
Are you ready for questions, Bapi?
Yeah, yes.
Okay. Our first question is from Al Aho. Would you please unmute yourself?
This isn't a question, this is actually a observation. I recently read the latest issue of the Journal of the American Academy of Arts and Sciences called Daedalus, and the title of the issue was AI and Society. It consists of 25 articles by some of the leading researchers and thinkers in the field of AI, and it presents a much more holistic picture of AI than I had seen before. You may have heard of a field called systems engineering. I think it was invented at Bell Labs in the 1940s and 50s. So this is systems engineering for AI, and it suggests that since AI is being used in all sorts of apps and tools by ordinary people, we should think about the societal consequences of using AI. Is it disenfranchising certain classes of people? Is it biased and causing certain decisions to be made because of lack of proper training data? Should there be a code of ethics for AI? Should AI be regulated, and how should it be regulated, and by whom? So these are questions that we don't have good answers to, but it shows how broad the field of AI has become. And it's an area that not only is of interest to computer scientists and mathematicians and OR people, but it's now of interest to people across the board in society. And if you've just watched any of the job postings, it's a great area for new people graduating from college to get decent paying jobs. So I recommend this AI and Society issue of the Journal of the American Academy of Arts and Sciences. It goes quite a bit beyond some of the issues that Bapi talked about, but they are certainly addressed in this issue as well. That's all I wanted to say.
Thank you.
Do we have any questions from anybody in the audience?
So, Bapi, I heard that a Google employee was stating that he thinks that his AI is sentient. Do you believe that?
I don't, because AI can, anything that's repeated and done in a mechanistic way can be done by AI, but anything that needs human, our brain is not going to be that difficult for AI, that's easy for AI to solve. So we promote AI to a point where it seems like it can do, as Al pointed out, it can do many things, but it really can't do things that needs the parallel computing power of a human brain. That's where it fails, in my view.
If I could make an observation about this, John, there is what's called a large language model in AI called GPT-3. And you give it a few hints and it'll write an essay or a story or a novel or a scientific paper on what you've asked it to write about. The last article in this journal of the American Academy of Arts and Sciences, they gave the final exam questions that they give at Oxford to GPT-3. And it then, in this article, printed the answers it gave. And the questions, I wouldn't be able to get into Oxford. I certainly could not answer these questions. Like the prompt was, there is no Marx without Lenin. Discuss. And then GPT-3 goes to say, many would argue that there is no Marx without Lenin. Indeed, one of the most common criticisms of Marx is that he failed to provide a detailed blueprint of what socialism would look like. And it goes on, written in very nice academic prose. The next question was, does Kant successfully refute Hume's skepticism? And the answer, I think it's an open question. If you are a Kantian, you will say yes, because Kant argues that Hume's skepticism is based on a mistake, and it goes on and on. So many of the observations, that is AI becoming sentient, is based on, I think, the language power of these large language models like GPT-3. And if you read these essays, you'd be hard pressed to say, was it written by a human being or by an AI program? In fact, one of the problems that many teachers have today is that they're getting tools like this to generate essays for their English assignments. And maybe the English teachers will have to become suspicious when they're too well written and too clever for what they expect of students. So we're, as Bapi has intimated, entering a brave new world. And I think we're just seeing the beginning of this world rather than the maturing of the world yet, because I think the full potential of AI has yet to be unleashed. And one of the perhaps most scary aspects is there's an article in this journal of the use of AI in weapons of mass destruction and warfare. And that is chilling. This is often a theme in science fiction movies, but we may be moving closer and closer to that kind of world. And maybe our kids and grandkids should start worrying about this. And this gets at the issue of how should AI be regulated?
Yeah, it reminds me of that movie when the computer was setting up the atomic war, and the last line was, "Want to play a game?"
Yes.
I have a question about GPT-3. Does that use some kind of informational database to help it format its answers, or how does it do that?
It's a deep learning model, multiple layers. I think it's been trained on billions of documents. So, and it's a neural net, basically, a multi-layer neural net with billions of parameters. It's impossible to predict what kind of answer it's going to give, but it's big AI.
I did want to mention something. When I was at Bell Labs, there was a person who wrote this program Fluff, and he wrote it in awk, okay? And what he did is you give it a word and would generate a sentence, and he'd feed that sentence back and would generate a paragraph. And he used it to write summary reports that he had to give to his managers about what he was doing. And I read that stuff, and it sounded remarkably human-like, like it knew what it was talking about. So I asked him recently if he retained a copy of that awk program, and he said no, he doesn't have it anymore. But so that was something he wrote, was a relatively simple thing, programming tool like awk, But anyway, Mitch Erickson has a question. Let's turn it over to Mitch.
Just a couple of comments. First of all, back to the issue of nuclear war and so forth. With AI and all that's going on right now, it would be really interesting to see a remake of Dr. Strangelove.
Yes.
And in terms of the papers being too good for the students, you can probably easily put in a coherence dial and dial the coherence back if you're like an 8th grader, and a little bit higher if you're a high schooler, and a little bit higher if you're a college kid, and just just put in a coherence multiplier, and the other thing I think is true is a lot of the stuff we see in the newspapers and online about sports reports are automatically generated these days. Basically, they take the line score and they string together a lot the events in the sequence, and use a few verbs, action verbs, and and say, and Judge hit a towering home run. I mean, that's pretty easy for AI to do. So I think we're seeing more and more of that stuff in things. I mean, not just sports, but beyond that. But the simple news reporting that. Think about it. It's really kind of easy to write up. And if you remember, Dutch Reagan used to do that verbally, based on what the ticker tapes were saying, and he'd get on the microphone and talk like he was right there at the game. So. And no comment on artificial intelligence at Reagan. So I'm moving on now.
By the way, I put some links on GPT-3 in the chat room if somebody wants to look at it.
Just a comment on that. What the schools do now is they can actually, they have a program that they use, and it can take a essay that a student wrote, and it'll actually find the original one that they copied from. So it's pretty cool.
Easy for teachers to check on.
Right.
And I last time I published a paper in a peer-reviewed journal, they came back with all kinds of things where there were obvious plagiarisms, and it turned out I was quoting myself, but that's still a no-no. But they have that. I think it was Springer maybe. They have all that stuff you know, and they use it to make sure you're not just, you know, cutting and pasting even, you know, like a 20-word phrase.
Well, the issue, I think, with tools like GPT-3 is that it will probably generate a different story every time you you trigger it with a slightly different prompt. So there's a lot of randomness in what it chooses to present as output. I might, I just looked at the last question in this journal that was given to GPT-3. And since we had a talk on incompleteness results, the prompt was, do Gödel's incompleteness results show that the mind is not well modeled as a computer? And GPT-3 comes back, no, Gödel's theorems do not show that the mind is well modeled as a computer. They show that mathematics is not well modeled as a formal system. So there you have it.
Al, can I ask a question? Miguel here.
Yep.
Right.
To what extent do you think, or are these programs dependent on the human language that is used? For example, I assume, or I get the impression that it's all in English. What if there were a different language or a translation program? We all know the phrase, you know, like the spirit is willing, but the flesh is weak. If you put that in Russian, it comes back, the wine is good, but the meat is bad. So are these dependent on the language that we're trained in, or could you run it through a Google Translate and get some logical results?
Well, Google's Translate program uses AI, machine learning, to translate from one language to another. And so for some reason or another, my speculation, again, and I'm not an expert in this area, is that these techniques are statistically based. They use mathematics and these neural nets to make the inferences, and they're language agnostic. Although I think that they must have some trigger saying, I don't know whether at Oxford they say, okay, you have to give your answer in Sanskrit or French instead of English. I don't know whether GPT-3 currently has that capability, but the big advance in Google's Translate program was made by Jeff Dean in using deep learning as part of the translation process.
Well, let me try my question. Would GPT function in a different base language?
Yeah.
I don't know it well enough, since I haven't used it personally, that what kind of results it would give. But it's been trained on a huge amount of documentation, so that's why it has such a breadth of knowledge, if you want to call it knowledge.
Yeah, it sometimes give you different script, for instance, like not only like it gives you different script, and that's sort of shows the power of it. Sometimes it can give different script from Google. Fine. Any other question?
Is there anybody in the audience that has a question? One thing I like to add about AI is, you know, people have studied the human brain enough to understand how the cerebrum is constructed. So it's basically a 2.5 foot by 2.5 foot sheet of, that's the thickness of a credit card, and they contain a column of processors, neurons, 6 levels deep, and they're all interconnected with each other. And there's no hierarchy to it. In other words, one can talk to any, you know, one can talk to its nearest neighbors, but they can also talk across the membrane, you know. So So in other words, there's a lot of things that are happening simultaneously. And I think until AI reaches the point where they can organize their neural networks in a similar way, I think they still have a ways to go before, they really reach human level of
Understanding.
thinking and organization.
Yeah.
I mean, at the moment, they're doing piecewise things, things are identifying with visual systems and, just concentrating on that and looking at acoustic data and just concentrating on that to do speech processing. But to get that overall level of organization is more or less missing. And I think the only thing that comes close is like the, AlphaGo developed by Google. Actually, they bought it up, but, So does anybody have any comments on that?
I just want to say thanks to Bapi for putting the time in and into making the presentation, including the whatever it is, 40, 50 years that you did warming up before you decided to write this presentation. So thank you. 50, 60 years, I don't know how long it is, but anyway, this is the kind of thing that is so cool about this group is that, people can dash off something that, based on their resident knowledge that, somebody else would take, days, weeks, months to pull together. And I'm not saying that Bapi just did this in 15 minutes, but thank you. Anyway, thank you, Bapi.
Thank you.
Thanks very much, Bapi. Okay, if there's no further questions, we'll conclude the MIG meeting for today.